Greetings, math fans. Alright, so today's lesson is, these are some applications using trig, and this is actually, we're going to talk about bearing problems. Alright, and you guys probably heard about bearing, right? A ship at sea, what is the bearing? We're at a course of, 53 degrees north, and etc. So, bearing is basically just using the compass, which compass is, of course, 360 degrees all the way around, right? You go north, south, east, and west, etc. All right, the key here, and I'm going to actually do this in red, and I'm going to draw a key. The key to all these problems is you have to have a picture. In fact, if you don't have a picture, I'm not going to give you credit for the problem. Okay, if you just have an answer and just some work there, you're not going to get any credit because a picture is got to be part of the answer. That is so huge. All right, very, very important. All right, so really there are two types of bearing problems. Or two types of bearing, I should say. Okay, the first, if I say it's a 60-degree bearing, okay, so what you're going to do is it's measured clockwise from due north. Of course, north being, if you think of it, it's like straight up. Okay? So, for example, a 60-degree bearing would look like this. Due north, and we're going clockwise. Alright, so that would be 60 degrees. Okay, the second type of bearing, so second type is you're going to start with a north-south line, which means up and down, okay, and you use an acute angle to show direction east or west from this line. Okay, so a couple examples here. If I said north 60 degrees east, that's the format it's going to be in. All right, that's actually the same as the first one we just did. So what you're going to do is here's your north-south line, and you're going to go east. And of course, you know east is to the right, like the east coast. Okay, so that's your angle, 60 degrees. Okay, it's pretty easy. If I do north 20 degrees west, okay, again, that's you draw a north-south line, and you go the other way. So that's going this way, right? So that's 20 degrees. Okay, the next one is south 40 degrees east. Okay, so now we're going this way, and you're going east. So again, you're going to the right, because the right is east. Okay, so that's south 40 degrees east, and the last one is south 80 degrees west. Okay, so you draw a south line and you go west, or you go to the left, like that. Okay, and that's 80 degrees there. So those are what everything looks like, okay, but you got to draw that north-south line. That's huge. So of course, just like quick terminology, right? A line which is vertical is north-south line, and a line that's horizontal is an east-west line. Okay, so that's really important. Another quick thing here too is something to kind of remember and keep in mind here is if I say that these two lines are parallel and I draw a transversal, you're going to see this a lot. These are going to be congruent. And what type of angles are those? Those are alternate interior angles are congruent. All right, you also have angles like this angle here and this angle here. And what are those called? Those are called corresponding angles, which are also congruent. As long as, again, those are parallel lines. It's very important. Okay. All right. So let's do a couple examples here. I have two examples that I want to start here. Now, before I even start these examples, I want to make a quick note here. First of all, these are kind of fakey examples. And you're like, what do you mean fakey examples? Well, everything is kind of based on a right triangle. So all these problems are going to have right triangles. Now, it's kind of a fake thing, because when you're a captain of a ship and you're traveling someplace, these things are not going to turn out to be a nice right angle. They're just not. And in a few chapters from now, we're going to actually get into triangles that are not right triangles, and that's actually where you get some good bearing problems. So for now, everything's going to be a right triangle. It's still okay because you're using some information that we've just learned, but these are not necessarily the most realistic type problems. So just kind of keep that in mind, and you should be good to go. All right, so let's do a couple examples here. All right, let's do our first example. Radar station A and B are on an east-west line. Okay, so right away, I'm going to draw an east-west line. Okay, you draw a nice horizontal line, and I'm going to label A and B. Now, the couple things that are important here, math fans, is I don't know if it's A is first and then B, or B and then A. And what happens is sometimes you draw it and then you realize after you do it that you drew it in the wrong order. Okay, then you have to go back and fix it. But I'm just going to draw it in this order. Okay, so A and B are an east-west line, 3.7 kerfometers apart, or kilometers, however you want to call it there. Okay, station A detects a plane. So station A, it detects a plane, that's our plane at C, on a bearing. Now, I'll tell you, man, this is a key word. When you see this word bearing, math fans, what you need to draw is you need to draw a north-south line. So basically, you're drawing a vertical line. And it's going to be dotted. Okay, because it's really not part of the picture. Okay, it's just showing you have to base it off of that north-south line. But I'll tell you, as soon as you see the word bearing, immediately you've got to draw a north-south line. So this is what we're going to do. Here it is. All right, north-south line. And it says a bearing of 61 degrees. So and I don't know how far to draw that. I'm just going to kind of sketch out a little bit. And this is going to be 61 degrees. All right, station B detects the same plane on a bearing. Oh, I'm going to highlight that again here. On a bearing, okay, on a bearing of 331 degrees. So what this is, we're going to put our dotted line here at B. And 331 degrees, that is from the north-south line going clockwise. So I'm going to actually just do this in red so you can see it easier. Right? Do you agree that well, up to the AB line, that's 270 degrees, and so we're going a little bit more. We're going 331 degrees. Okay? And that is going to be to this line right here. Okay? So that's pretty mellow there. And we actually have our triangle, and this, of course, is C. Now, it's a little weird because you kind of have to put a few things together here. First of all, I know this right here is a right angle. And the only reason I know that is because I drew a bearing line, which is a north-south line, and it initially stated that it was an east-west line, so I know that's a right angle. So with that in mind, I know that this angle right here, angle A, is going to be 90 degrees minus 61 degrees, okay, which is 29 degrees. So 29 degrees. And then this one is 331. Well, do you guys agree that from this point to here, right, isn't that 270 degrees? So if I want to take 331 degrees, the whole thing, and I subtract, so 331 minus 270, that's how I'd figure out just that angle, angle B. And if I subtract that, I get 61 degrees. So that's 61 degrees. And if you notice, I told you back in the day, you were never going to subtract from 270 or 90. That's only when you're doing problems with reference angles. So this has nothing to do with the reference angle. This is strictly, we're doing a bearing problem. All right, so this is what you have. You have a triangle. I'm going to kind of draw this triangle separately here just to kind of show you what you have. This is 29 degrees. This is 61 degrees. And if you add those two up, isn't that 90 degrees? That means this is 90 degrees. That's actually really significant. You have to show me that it's a 90-degree angle. Remember I told you it's a little bit kind of fakey here a little bit, but you have to know that you got to prove to me that it's a 90-degree angle, as opposed to going, well, yeah, it's a 90-degree, and I can just do give you my answer. All right. So anyway, that's your triangle. It's 29, 61, and I am going to we're just looking for the distance from A to C. So I'm going to call that little b, because that's truly what it is, across from the B. All right, so I'll draw the triangle one more time here, just so it's clear. It's a right triangle. This is 29 degrees. This is 3.7 kilometers. And this is 61 degrees. All right, and I'm looking for B. So this is A, B, and C. All right, and then it's just a matter of using trig. All right, so I'm going to use, it doesn't really matter which, if you use the 61 or the 29 degrees, because they're both given. I'm going to use the cosine of 29 degrees, and cosine because it's adjacent over hypotenuse, which is b over 3.7. Okay, and then I cross multiply, and that actually is pretty nice. I get b is equal to 3.7 cosine of 29 degrees. So b comes out to be 3.24, and don't forget your units. And so that is the answer to that problem, 3.24 kerfometers, or kilometers. All right, so I taught you guys a lot of different things here. I'm going to be very particular in how you solve these problems. All right, let's look at problem number 2. It's actually a little bit more involved. Okay, a ship travels 40 kilometers on a bearing of 27 degrees. So we have nothing really to start out with, but we do actually, because we are going to draw, you see the word bearing, I'll highlight that, on a bearing of 27 degrees. So I'm going to draw my line there, and let's just make a sketch here, and that's going to be 27 degrees. Then it travels on a bearing of 117 degrees. So I went from this point right here, we can call this A, and I went to B, and then I'm traveling another bearing. So I'm going to draw another dotted line right in that spot because that's my horizontal line. And it travels at 117 degrees, so that's going about this way, right? Because if I draw, here's my angle, isn't that 117 degrees? Okay, I can kind of extend that a little bit more up. Okay, that's 117 degrees. And then, and this is for 140 kilometers. And here, let me label this. This is 40 kilometers over here. Okay, and then it says find the distance from the starting point. So that was B, and this is C. So I'm looking for AC, and I'm looking for that distance. So we're going to call that little b again. So we're given a bunch of information here, but it's not quite as easy as before, because I don't want you guys to look at this. This is actually really bad to look at this spot right here and say that's a right angle. Okay, it just happens to look like a right angle, but actually it's not a right angle, so that is really bad to assume that. Because it's not an east-west line, so we don't know that. All right, but we do know a couple different things. Remember I told you corresponding angles and look for alternate interior. That's really important. And I have this 27-degree angle right here. Isn't that the same as that 27-degree angle right there? Because aren't these two dotted lines that I just drew, aren't they parallel? Because they're both north-south lines. So this angle is 27 degrees here. A little messy. 27 degrees. All right, and then if that's 117 degrees from here to here, what if I go, isn't it the same thing to go additionally here? Isn't that going to be 180 degrees? So can I just figure out this angle right here and say 180 minus 117? Doesn't that give me that little spot right there? Okay. And so that would 180 minus 117 gives me 63 degrees for that angle. So now I know, let me redraw this picture because I think it's good when you redraw it without those dotted lines. Well, actually, I do need to draw this one dotted line. So this is 27 degrees, and this is 63 degrees. Not to, of course, not to scale because it doesn't even look like that. And so if I add these together, I get 90 degrees. Hey, 90-degree angle. All right, a little messy, so let's draw it now a little bit more to scale here. Like that, and like that, and like that. Okay, so that's a 90-degree angle, which is important. And then this is 40 kilometers, and this is 140 kilometers. And I'm looking for the value of B. Okay, so I happen to make B my right angle, no big deal. Now, what do you have to do? There's no trick involved here, right? There's really, it's A squared plus B squared equals C squared. That's all it is. So I'm just going to say it's B squared. Kind of looks weird because I'm saying instead of C, right? B squared equals 40 squared plus 140 squared, just Pythagorean theorem. So I get B is equal to 100 after I take the square root, right? So B is equal to 145.6 meters or kilometers. Okay, and that's the answer to that. It says, you know, how far is it from the starting point? Is 145. So that's pretty easy. Again, I showed you a bunch of different things here. For this problem, definitely bearing lines, and then looking for, in this case, you had a supplementary angle, and you also had alternate interior angles. And then you had to determine what was the right angle. Now, if you chose not to do all that work, and you just looked and said, geez, I bet you it's going to be a right triangle, and you went right from the problem to 40 squared plus 140 squared, took the square root and got an answer, I would give you 0 credit because you didn't draw a picture and you didn't prove to me that it was a right angle. All right? So that's it, math fans, with these kind of problems. Again, you just got to be really careful and draw lots of pictures, and you should be good to go. All right? Have a good day, math fans. Goodbye.